Hello! Alright, I've been jumping all over the place, did a reshoot, and so now, officially, the edit is locked, and I'm actually sending it off to the sound team. How many times have I said that? But I'm doing some digital extensions, which is fun. Finished up that one shot with the flying vehicle, except I think I'm gonna render it higher res, because this has got some weird kind of aliasing things going on. I think I want to do a tutorial about that superstructure, because that came together really easily. Did some other stuff, weird shots for the ending, not gonna show a lot of those, but fun putting Caitlin in a little cube. A lot of little updates. But today I want to try to fix a shot that's been bugging me a little bit. So I thought it'd be cool to get some kind of like techno monks in there. So we did this shoot a couple years ago. This is the same three people like twice. But unfortunately it looks exactly like what it is, which is that we just went in our garage over to the costume bucket and put all of them on. And so I wanted to try to see if like at least one of these people we could track and put something a little bit more legit looking on there, so it doesn't just look like we took all the dirty rags and draped them on ourselves with like whatever tubes and gaff tape we happen to have. So the difficulty with this is that this was not shot with that in mind, so there are no tracking points or anything like that, and so this is going to be hopefully more useful because of that, because it isn't just going to work automatically. But first, I want to start with something easier. Caitlin and I have been watching the WandaVision show, which is very fun, but there's one character in it who has a cape. I don't think that spoils anything, but when they do the cape, it is CG, which they've done for a long time. I think they said back in like 2010 when they made the Superman, like that cape was always CG, or it was something like that. And so I just filmed some footage, and I want to see if we can add a cape. This may not work as well as I would hope. All right, and here in Blender, I'm gonna go up to the top, click the plus, and create a new workspace that's motion tracking. Go in, load in our footage here. Woo! And you can see it's just me shimmying and shaking a little bit, trying to get some sweet cape action. I'm gonna set scene frames, which will limit the composition to the length of the footage, and prefetch, which is gonna load all of the footage into RAM. So I thought in this case I was actually setting myself up for success. I was like, just 3 tracking points, this will be easy. But I'm underneath a bright light, and both the tape and the Sharpie are a little bit glossy, which means as I move around, there's this highlight moving over the tracking point. And since the tracker's just looking for the same pattern of pixels, having this big bright light moving over the top of it is gonna throw off that track. And so that kind of demonstrates the importance of doing test shoots. If you're ever gonna have like a character with a robot hand or a face thing, do some test before you get there on the shoot day, because if I filmed a bunch of shots with this, most of my post issues would just be trying to deal with the fact there's this sheen on it, which could have been really easily avoided by using like just a matte piece of paper or something like that, or maybe a more high contrast printout or whatever. All right, so we've got that. Since this is 4K footage, you can see if I control click to add a tracking point, this is fairly small, and if I put that on a tracking dot, it's a little bit too small, because we're going to be searching for whatever's in this box. So I'm going to blast this up to be like, I don't know, maybe 60, which is the Blender tracker just got an update. It is ridiculously fast now, but changing the pattern size to be this large is maybe a bit much. And the search size is I think the number of pixels it'll look in any direction for that same pattern, which also slows things down pretty quick once you raise it up. But I'm gonna try like 400. For motion model, let's change it to location and rotation, since the tracking point is basically just doing this. We don't have to deal with perspective much. And I'm gonna normalize, because that might help us with the fact that there's moving shadows and highlights and stuff. So I'm going to control click on that tracking point. Yeah, that looks okay. Put it in the center. You can just hit G and R and S and box select and all that stuff like you normally do in Blender. Get that centered and go down here to track forwards. Hey, all right, it's working good. Oh, all right, here comes the jump. Oh, and we lost it. And so that just means I'm gonna go back to the last frame where it worked, just tweak it a little bit. And what that means is now, instead of looking for the very first frame for that pattern, we've updated the pattern it's looking for. Now it's looking for this pattern. And it seems to be doing okay. We'll see what it looks like when he comes back down. Oh, it's working great. Oh, all right, we lost it. recenter, track forwards. Cool. All right, and I'm gonna go back to the beginning, control click on the next one, and just do it again. Hey, all right, didn't have to babysit that one at all. Save the hardest one for last because this one has the most highlight. But let's see how it goes. Oh, all right, I'm gonna go back. Hey, all right, that one did really good too. So we've got our 3 tracked points, and we don't even have to solve this. We just can use this in 2D space because it's such a simple situation. So I'm going to select all of these and go under the Solve tab. Here, let's set this as, we'll set it as a background. Loads it up into our viewport up there. And under Geometry, I'm just going to say Link Empty to Track. And if I click that, you will see that we have new empties where every tracking marker is, and they just move around the same way they do in the footage. So, cool. All right. And they're attached to the camera, so I'm gonna, let's create a human-sized cube that's about this big. And we'll try to line these up so that they're more or less positioned how they would be. Cool. All right, that looks about right. Here I'm going to jump over into layout, and okay. And I'm actually going to swap out this footage because right now this is still the 4K footage, which you can see plays pretty slow. So under the camera here, I'm going to click on the camera settings, open up the background image, and I'm just going to load in cape smaller, and now it plays back real good. Here, let's grab these and shrink them all down. Okay, so adding a cape, I'm just gonna add a plane here, line it up. Let's see, let's try to get it about the right length. Is that? Yeah, that's about cape sized. Apply the scale just in case. I'm gonna shrink this down. Cool, and I'm actually gonna make the cape start pointed out like this so it can kind of fall into position. Gonna line it up. In edit mode, I'm gonna hit Control R, add an edge loop here so that I can right click and it keeps all the squares a little bit more square. And I could probably do more edges, but I think this will work okay. Okay, and we could just jump straight into making it a cloth sim, but I'm going to attach the shoulder points first. So when you have a cloth sim, you obviously have to say which parts of it aren't really engaged in the sim, the parts that are attached to the rig. So you're basically you're stapling them to the shoulders. So we have to say which bits we want. So let's staple this bit and this bit here. So with those selected, I'm going to create a new vertex group, assign, it'll assign whatever's selected, and we'll just call this the stapled bits. Cool. And now we also have to say what they're stapled to. So with these selected, I'm going to hit Control H, hook to new object, and that just means that now this empty controls those vertexes. I'm going to do the same thing over here to a different object, hook to new object. And now if I parent, oh, we're down here. Can move them up to match. And now if I parent these to this, Control P, woo! You can see it's dragging around just those bits. And so if we have the cloth sim deal with everything else, it should in theory work. So let's try to do that. With this selected, I'm gonna go into the physics tab, and just check cloth. And right now it'll ignore the pins because we haven't set that up. So we gotta go down to shape and just select the stapled bits. And now, ideally, hey, we've got our cape going on. And because we parented the these vertexes to these other empties instead of the original tracked empties, that gives us a little bit of control. So here, I'm gonna bring this up and kind of line it up with the shoulders a little. So ideally, that works better. And let's right click, shade smooth. Hey, all right, that works. That works okay. I think we could probably add some more, subdivisions and stuff to all of this. In fact, I don't know. Let's see what happens. Right click, subdivide. I don't want to subdivide the bits I've already hooked to the new object just because I feel like that could be a little bit wild. But hey, that's working pretty good. And if we want, we can add a force field. Have it, gotta probably crank it to be like wild. Let's see, 1,000. Oh, that still doesn't look like it's, I guess it's doing a bit. We just have to go nuts. Yeah, now the cape's blowing in the wind. So you might be wondering, what was this butt tracker for? Well, I'll show you. Let's, this was just an idea, might help the interaction a little bit. I'm gonna create a cube, just thinking about my own butt. It's very cubic. And I'm gonna hit Control B to bevel it. Okay, line this up down there, and I'm just gonna parent this to that. And if I select this, set this as a collision object, and here maybe under the view properties, I'll make it wireframe. But ideally now the cape will actually. Yeah, there we go. Dun dun dun. So anyways, this is how you achieve realism. And if you wanted, you could add like legs and stuff. It's really easy to add collision objects. You could just add this by hand. I just thought it'd be more fun to try to track it into. So yeah, we'd probably actually want this to be more, you know, forwards a little bit. But yeah, that's cool. That's maybe it's still a bit much, but all right. Let's try something a little bit more complex. And also, just because I should say it every time we talk about physics stuff, when you have it how you like it, you want to go down to cache and say bake. Or if you already have, you can see down here we've got it all blue. I think that means it's in cache, and so you just say current cache to bake, and that'll keep it. So when you render it, it'll actually save this instead of glitching out. Alright, so back in a raw scene, click plus, VFX motion tracking, gonna load in the footage, costume enhancement, cool, and set scene frames, match the length, prefetching into RAM, we've done that before. So typically when you're doing a motion track, you don't even have to know your camera data, really. You can just track the scene and it'll look at the way all the dots are moving and be like, okay, we think you have this lens, we think you have, you know, I think it can estimate sensor too. My camera sensor happens to be the default that Blender assumes sensors are, and so I haven't really had to deal with that. But let's go under track here, and I'll show you what I mean. So first there's the camera track, which is what it tracks first by default, and then we click plus, and we can start adding individual objects within that camera track, which is cool. But in this case, again, the camera isn't moving, so there's nothing really to track. And so we're just gonna give it some information and say, hey, this is what you are, you're not gonna be moving, and I think that should still work a-okay. So under camera here, sensor width, yes, it was 35, and by coincidence, the focal length was 24. I was on my widest, I was on my 24 to 70 lens, as wide as it goes. So this does match the camera. So that's cool. Which means we can go straight on to the next step, which is adding an object. Here, let's call this torso. And jumping over here, I think these pattern sizes and search sizes are okay because they're not moving all that fast. It just has to track, you know, a little bit. Okay, let's set scene frames. That said, I'm going to change the motion model to affine, which deals with perspective shift and skewing and all that a little bit better. I'm going to normalize. And under the tracking settings, I'm just going to set the correlation lower so that it'll keep tracking, even if it's not quite so sure if it's making, you know, the right decision. Okay, we're going to use detect features. So first, let's define an area for it to detect the features in. I'm going to hold down D for draw, I guess. And I'm going to go to the middle. Just so that, again, more likely to have trackers at the beginning and the end. Hold down D and trace just around this torso. I think this entire chunk should move more or less as an overlap there, as one piece, just kind of a big torso bit. Detect features, scatters all over, so let's open this and just say whole frame inside annotation. Cool. I'm going to change the threshold to like 0. And the distance to, I don't know, 20? Haha! That's a lot of them. Sure, let's see if it works. I'm just gonna click backwards, and look at that! The new Blender tracker is very, very fast. It's tracking all those points very quickly. I think we probably got some good ones there. Going back and Going the other way. Go, my little tracking minions, go. Okay. All right. Hopefully that gives us something. I'm gonna go into solve, and right off the bat, I'm gonna go down into cleanup. And these seem backwards. It seems like you should do the top one first, but you actually usually want to do the bottom one first. And I'm gonna try filtering anything that's wow. Oh, maybe we won't filter it. Okay. I'm just gonna try solving it. Here, let's set better keyframes. Again, we want something that shows some perspective shift, and so maybe frame 100 and frame 20. So 20, 100, solve object motion. And it's very quick. Hey, all right, 12 pixel error. That's cool. Now, so that means it's made certain assumptions about the way the object's moving, and we can compare that assumption against what the pixels are actually doing by going down to clean tracks, and that's the reprojection error. So let's say any point that's more than 5 pixels away from where it thinks it should be, or maybe we'll go up to 10. We'll select those, and we can just delete those, so it won't even consider them. And ideally, this will have gotten rid of a lot of these squiggles. So you want these lines to be as unsquiggly as possible. In fact, we can just go through and delete some of these particularly outlier ones. But here, let's just try resolving with all of those deleted wacky ones. 4 pixels, that's really good. Okay, let's try cleaning again and go into the reprojection error of like 3. 4. I like doing it incrementally. All right, solve object motion. 1.98, and again, this is a 4K footage, but I'm only exporting a 2K, which means this is actually more like 1 pixel, which is getting into a very good area. One thing we can also do, if we're going through and we can see that the tracker glitches out at a certain point, we can just say, here, where's a good problem one? This one looks like it's working okay, but around this point it goes off the rails a bit. We can just click this button, X in that direction, and it gets rid of everything after that point. Same with like right here. For most of this, it looks like it's tracking pretty good. It's just this beginning area where it's going a little nuts. So let's say from here forwards, we'll just delete that, and maybe same with this one, and that one, and that one. We've already got something that works, so this is just refining a bit. Okay, solve object motion, 1.89. Doing it one more time. Reprojection error of 2. 1.29 pixels. Okay, I'm gonna say that's good. Cool. So now that we have this data, I'm just gonna jump back into the regular view, and this will be our camera. Make sure that it's at 24 millimeters, just like the real camera. I'm gonna jump into the constraint tab here and apply a camera solver, but nothing's gonna happen because, again, remember, we didn't actually track the camera. But this will give us a good point of reference. Gonna go into camera view here, and under the camera options, I'm gonna load in a background image, and instead of the 4K footage, which would bog everything down, I'm actually gonna load in a lower res version, just smaller, but it should still work the same. Although, click this button here to make it actually the right length. And ideally, it doesn't really matter, but I want to line this up with the floor a little bit. Cool. All right, that's looking good. All right, so how do we actually use our motion track? I'm gonna throw a cube in here. Cool. And I'm gonna give it an object solver constraint. So under the constraint, add object solver, and it wants to know which object we want. We want to use the torso data, and the camera it's using is the only camera in the scene. Right now it's disappeared, so you click set inverse, and I don't properly know exactly what that's doing, but it's now using the data. It looks bad, but that's because the further away you get from the object, the more it's going to be wiggling. So if we line it up with the object, it'll be better. One way to do that is to turn the motion tracking on under the overlay settings. So check, here we go. If we line this up with that, we should get a pretty solid looking track. Yeah, that's fun. It's a little jittery, but you know what? I think that's actually going to work a-okay for our purposes. Let's do one more track. Let's track the head. Oh, one more thing I should say. When you do an object track, it doesn't know if it's a tiny thing up in the foreground or if it's like a big thing in the distance. It has no way of knowing how far away something is. And so you have to set that yourself under object scale. And you can see here, when we change the object scale, it either gets really big or gets really small. I'm not doing any physics anything, so I don't actually have to match any particular scales. So I might just use this setting arbitrarily, but yeah, there we go. And you can see, as far as the camera is concerned, it hasn't changed anything at all. Okay, so we're back in here. Let's just track the head. I'm gonna go under, let's see, is it marker? No, annotations. I'm gonna delete the existing annotations, and let's see, under track, I'm gonna click plus, and this is gonna be head. Cool. Gonna trace the head. We're gonna do the exact same thing. Detect features. Detects a lot of them. Go forwards. Go back. Delete some of these problem ones. Just click on them and hit delete. And hopefully we'll have enough data when we're done. And again, you can also filter tracks if you don't want to do this by hand. But this is looking, that's looking pretty good. Let's see what happens if we try to solve it. Probably do the same thing, 20 to 100 for the keyframes. Solve object motion, 3 pixel error, that's pretty good. So we'll go down to clean tracks, and anything more than like 2, ooh, 4, yeah. And again, if we scrub through, those are probably the ones that are glitching out a little bit. Sometimes affine trackers can look like they're glitching out, but they just like to really show off their skew. But I'm still going to delete those. Try resolving. 1.85. Clean tracks again. Let's set it to like 2. Solve again. 1.7. And remember, because we're having the resolution, that's actually more like a half a pixel. So I'm very happy with that, which means now we can jump back into layout and hey, look, we've got our new cluster here. Let's line up the distance for that so that it's above there. Under the track settings, or no, solve settings. Increase that scale, just like we did. Cool. So now we have 2 individual tracks, so I can create a new cube, line it up with the head, add an object constraint. The object's going to be the head, and the camera is going to be the camera. Set inverse, and cool. Now we have honestly, the head and the torso seem to be doing mostly the same thing, but we've got 2 individual tracks to play with, which is fun. Okay, so how do we want to incorporate our costume onto the person? First, I want to get some sort of mesh on there to represent the person. So I'm going to bring in the dude mesh. This is just a humanish mesh. Gonna line it up here. Actually, under the overlay settings, I'm going to change the scale of the axes to be a little bit smaller, so we get a better sense of what's going on. All right, let's try sticking this kind of in the point cloud. Yeah, that seems to be pretty good. Here, I might delete the head. I just want the torso for this one. All right, we've got our decent head. If we want, we can use proportional editing to pull stuff around to really make it match, but I'm not even all that worried. Object constraint, object solver, objects the torso, camera's the camera, set inverse, and now this follows that motion. And there are some jitters, but we'll actually deal with that at the end. I'm not worried about that. For the colors, we're not going to render this torso, but it is possible that light will be bouncing off of it. And so I want to give it a kind of brown color, just so that if any light does bounce off, it'll kind of be tinted brown and it'll work okay. And the reason for that is we're going to be using this as a shadow catcher object. So under object properties, under visibility, or oh, are we in Eevee right now? Go into cycles. I don't know how well shadow catchers work in Eevee. But you could just Google Eevee shadow catcher and find out. But I don't actually know that off the top of my head. But I do know, if we go into visibility now in cycles, we have this shadow catcher option. If we go into rendered, it works okay. So shadow catchers are bizarre because shadows aren't a thing, really. It's just a place where light hasn't, where it would have hit, but it's been blocked or something, and there isn't a particularly great way to solve for that. Like, imagine you have a light on an infinite plane, and like, at what point far away from the light does it get dark enough to be defined as a shadow? I don't know. It's funky. I don't exactly know what their rules are for defining a shadow, but I do know it can result in some weird artifacts. So I'm going to get rid of the hard lighting for now, and I'm just going to use the world shadow for now. Okay, that looks like that's working. Here I might put this on a different layer and turn that off. Cool. So now we just get to model some sort of costume around here. I'm gonna go nice and basic, like just a weird tech thing. Oh, I shouldn't have rotated it. Not totally sure what I'm going for here. But I think I like something kind of like this. Yeah, that's kind of fun. Here, let's create a little shoulder pad deal. All right, just modeled something kind of boxy. I'm gonna, let's give it a material. New material, base color as an image texture. Just gonna load in something like that. And let's see, material view. I'm gonna hit U cube projection. Cool. And slide open a UV editor. And let's see, let's load in our metal container. Let's just try to line this up so that it kind of, yeah, we'll just put the seam right there on the edge. And that's kind of bizarre. If I were very serious about this, I'll probably go through at some point and like really up-res this. But yeah, that's kind of fun. Oh, oops. Go back to the right frame. And I'm gonna parent this to the torso, which already has the constraint on it. And look at that. He's got a big old funky robot head. Here I might shrink this a little bit because it's a little too large, I think. That's fun. Cool. And this is what it's looking like. I'm just making the world a little brighter to try to match it some. And right now I have this set up so that if I check, if I go under render settings, and hit render, it should render with an alpha 0 background. So if I render it as a PNG sequence, I can just comp it on top in After Effects. But in the motion tracking settings, if once you get the track set up, you can click set as background and set up tracking scene, and it'll actually set up all of the render passes and everything. So it'll actually do it all for you in the Blender compositor, which is nifty. I just don't do that as often. Okay, so you might be looking at this thinking it looks just a little bit too jittery. Because it's supposed to be like a heavy object, and we can actually still tweak this. Here, I'm going to select the torso object, and under the constraints, I'm going to say constrain to F curve, and that just turns it into a bunch of keyframes instead, which means if we open up the graph editor, we can just tweak them however we want. We'll be like, woo, and clean it up that way. Or we can select everything and hit Alt-O, and that just smooths it out. And so now, look at that. That just stays nice and smooth. So that's a fun way. We didn't even use the head track. Ha! We could if we wanted, and add like little tubes and stuff connecting between the two. That'd be kind of fun. So that's a basics. That's both kind of an easier way and a harder way of how you can do costume type augmentation, even if you didn't have any trackers or anything on the day. Obviously, it's a little easier because there's a lot of gunky texture data here on these costumes, but it's fun to know that we can do this and it isn't all that hard, actually. I mostly did this just to prove to myself that motion tracking isn't as scary as I as I think it is. Because I'm always like, oh, I don't have the right tracking points or whatever. But this was not all that hard at all. So I guess I'll upload this footage in case you guys want to do anything with it. And yeah, hope this was kind of fun.